Session 3, Unit 7, Module 1. All right, so let's take a look at what is on tap for today. It looks like we have another problem string. It seems like it's our 10,004 problem string. This one still deals with the partial products and partial quotients. We're going to use parts to figure out answers, right? We're not going to necessarily use the standard algorithm. We're going to break down these problems into partial pieces, and hopefully we can figure this out. We have a workplace game that I'm going to be introducing to you today. It's called Roll 5. And then for homework for today, all you have to do is student book page 260. All right, with that said, we did have some homework last night. If you go ahead and open up your student book, look at page 258, pause your computer or pause the video and make sure that you have written the correct answers. If you haven't, go ahead and erase the answers and fix what you need to fix. Start the video when you're ready to move on. Now in your home connections, more array work. It seems like we're being blasted with arrays right now, but that's okay. Go ahead and look at the answers that you wrote, look at the answers that are provided for you, and then go ahead and change your answers or contact your teacher if you're finding that you're just not getting what is being taught. Okay? All right, so now we are going to go back to more partial quotients. Now you remember this? Remember we asked you to kind of think of a math problem that you would know that we would be able to build on and figure out. So as I'm looking at this first one, 280 divided by 14, my eyes are kind of drawn down to the bottom. Now on the bottom, it looks like or the one below it says 28 divided by 14. Well, that's one of the easier problems for me, right? 28 divided by 14, that equals 2, right? And so then knowing that 280 happens to be 10 times what 28 is, and if I'm dividing it by 14 still, my quotient or my answer should be 20 as well, or 10 times as much. Okay, so now let's take a look at 308. Well, might as well use, since we're dividing by 14, we might as well use 280, right? Because we know that's 20 already, right? And we know that that's more. So we just have to figure out how much more. So how much more is 308 than 28 or 280? Did you get the answer? 28. And we know that is 2 times, right? Based on what this problem is. So I use my partial quotients, and I know that 20 plus 2 equals 22. So 308 divided by 14 is 22. Okay, and we can use it the other way, right? So it's 252. So we have to take the 280 because that's the larger number. And what's 252? What is that difference? Did you come up with an answer yet? It's 28 again. And again, we know that 28 divided by 14 is 2. So instead of adding 2, we're just going to subtract 2 because we used subtraction here. Well, this number, the 252, is smaller than the 280. Here, the 308 is larger than the 280, so we're going to be adding, and it gives us our answer of 18. Awesome. And now we're moving. Okay, how about this 2? How does 2,800 compare? Well, looks like it's 10 times what this one is, or 100 times what this one is. So then it must be that my quotient needs to be either 100 times or 10 times what this quotient is, right? So 2,800 divided by 14 is going to equal 200. So then when we get over here to 3,052, Now we have to figure out what the difference is. So what is the difference between 3,052 and then subtract 2,800? I'm going to let you go ahead and pause the video and figure that one out. Okay, so we're all back. What did you come up with your answer? Right? 252. Oh my goodness, what did you notice? 252. Could we use any other? Oh, we already know that. We know it's 252 more, so we have to add 18 more, right? So that's 200 plus 18 to give us 218. You see how easy this division is? Whoa, we're just flying through this. Now, how about this 2,786? But we have to start it with a larger number, which is 2,800. And we're going to subtract 2,786, not 1,000. That's going to give us a different answer. 2,786. And what is that answer? Did you come up with it yet? Oh, yeah, it's 14. And since it's less, we're going to subtract. So we're going to go 200 minus 1, and that's going to give you the answer of 199. Now, how many of you have been able to do 199 in your head, right? I wouldn't have been able to figure that out. I would have needed to use the standard algorithm, and I would have had to have spent a lot of time with paper. But now I realize, oh my goodness, look how close look how close that 2,800 is, because I know 28, I know 280, so it must be the same pattern, and now I can figure this all out in my head. So what do I do with this next one? This next one's a little bit more difficult, but I think we can get it. 462 divided by 22. See, this is what they always do in these problem strings, right? They get you going on a pattern, they get you going feeling pretty good, and then bam, they send you one that does not fit any pattern. But I think we can get it, right? So 220 or 22 times 10 would be what? Right? It would be 220. Well, that's still kind of low. What if we go to 20? So what is 22 times 20? What does that equal? All I have to do is double it, right? I knew you knew that because you're pretty smart. That's 440. We're almost there. So what is the difference? Well, I'll go to 462. Let's subtract 440. And what do you get? This is all stuff that you can do in your head. I'm just showing what it would look like down on paper. Right, it's 22. So all I have to do is, we know that's one more, right? So I already have 20, and I'm going to add one more. So my answer is 21. You see how that works? Awesome. I knew you would. All right, so now let's get to a little bit of fun. It's been a while since we learned a workplace game. So we're going to play a game called Roll 5. So for this, you're going to need 5 dice or 1 dice that you're going to roll a few times. All right, so initially what a player is going to do is you're going to roll 2 dice, or you're going to roll twice, and you're going to multiply these digits to create a target number. So if you roll a 2 and a 7, you get 14, right? We're going to multiply those digits together. Don't use ones, okay? So use all of your other numbers but ones. When you roll, only because I'd like this to be a little bit more difficult. Well, maybe not. You know what? Use the ones. I'm good with it. When you're done, then you're going to roll either the dice 5 times. You're going to roll your Yahtzee dice and come up with 5 different numbers. And with that, you're going to add, subtract, multiply, or divide any combination of those 5 digits that you rolled to try to equal your target number. And that's that number you rolled when you rolled twice and multiplied it together. You're going to record your equations. Make sure you're using the proper PEMDAS, the order of operations. And you are awarded for 1 point for each digit that you used, right? You will get an additional point if you use multi-digit division. So if you combine a 1 and a 5 for 15, but you can't use the 1 or 5 again. If you made it into a fraction, 1/5, or if you used a decimal like 0.25, right? So we're looking for points here. Now the player with the highest score after 4 rounds wins. So let's take a look at what the game board looks like. Here's what it looks like. We have our target number. You have 5 numbers that you're going to roll. You're going to make your equation, and however many, because you're going to try to hit that target number. And then when you're as close as you think you can get, your points that you earned are players record their equations and are awarded 1 point for each digit used. All right, so I have a kind of link up here, which will kind of explain things, right? I'm going to toss. This is a little bit more different than the dice that you may have, right? The dice that you might have, one dice is 1 through 6, and then our second dice is 4 through 9. Who has a dice that's 4 through 9? So your 1 has to be a 4, your 2 has to be a 5, your 3 has to be a 6, your 4 has to be a 7, your 8 has to be 7. Your 5 has to be an 8, and your 6 has to be a 9. So you might want to write this down on a piece of paper so that when you roll it, you kind of know it. So your first one is 1 to 6. Your second dice will be 4 through 9. And then here are your 5 digits that you're tossing. All right. So we're going to toss. I have a 5 and a 7. So my digit, let me see if I can move this, is 35, right? So now I need to let's hide that because we don't need to use any of that. We are back to now we are rolling our dice. So let's toss our dice. We have a 5, 2, 3, 6, and 7. So I'm going to write my digits down. 5, 2, 3, 6, and 7. All very easy. You can find this anywhere, right? So now what I'm going to do is I'm going to look. I know, and for my math facts, I know that 5 times 7 is 35. So that's going to get me right there, right? But I'm going to put that in parentheses because I'm going to do that first. And then I have this 2, 3, and 6. So how can I incorporate this 2, 3, and 6 to help me get close to 35? Well, I'm already there. So I need to find some way. I can either use my 2 digits, right, and take my 2 points and be done. Or I can try to get more, right? So I am going to subtract in parentheses because I want this done. 2 times 3, right? But I'm going to subtract 6. So regardless of what I put here, as long as I don't put division or multiplication, I can add or subtract, right? Because 2 times 3 is 6, because I have to multiply first. 6 minus 6 is 0. 5 times 7 is 35. I hit my target, and I have awesome. So I have 5 points for this round. Now, if I would have divided by a multi-digit number or multiplied by a multi-digit number, or if I would have um, used fractions or decimals, I'd have got some bonus points for each one of those, but I didn't. I just got my 5 points. You're going to carry on through 4 rounds, and then you have your final total score versus your friend's total score or your parents, and that's the game. Okay, fairly simple. You just need some dice, and then you need to also consider. Remember what I said. You have 1 through 6, and then for your second dice or the second roll, a 1 is going to be a 4, a 2 is going to be a 5, a 3 is going to be a 6, a 4 is going to be a 7, a 5 is going to be an 8, and a 6 is going to be a 9. Or, if you just want to just be a little bit easier, you can just multiply the 1 to 6 again. If you want to make it a little bit more difficult, which I know many of you would like to, do it that way. All right, so that is roll 5. Many of you have this game posted on Seesaw somewhere. Please go ahead and play a game. Post your final score. Let us see how you did. Did you win? Did you not win? Okay. As you're playing, these are some of the questions I want you to consider. Was there another expression that would have resulted in your target number? So could you have kind of shifted things around, right? And done it a different way, but still came up with the final target number? How can you determine if you wrote the equation that you said correctly on your paper? So are you using PEMDAS? Are you doing your parentheses first with your exponents and then multiplication and division and then your addition and subtraction? Make sure that that's what's happening. And can you include division and fraction and decimals in your equation to earn the additional points? So challenge yourself. I know you can do it. Do your best. All right. So once you're done playing your one round and you posted your scores, and I know you're going to do well, go ahead and get that student book. Do page 260. You also have some time to do your online 7 resources or your April or May number corner resources. All right. So I hope everything's going well for you. If you're kind of confused on that game, take a look. I believe the rules are in your student book, page 200, and I believe it's 259. That's going to help you out, and just have fun. Good luck. It's math, right? Contact your teacher if you're having any problems. If not, awesome. Have a great day and enjoy math.